So module 6 has properties of acids and bases, and it's pretty much just asking, like giving you the introduction of what is an acid and what is a base. In terms of acid properties, acids are corrosive, they have a pH of less than 7 and they taste sour. And here's also the naming of acids. So if you have a hydrogen ion and a halide, the suffix becomes IC, and you have a hydro as your prefix at the front, and then you just write it as acid. So in this case, for let's say HCl, it'll become hydrochloro, because we're not including that and we're shortening it, it'll just be chloro, and then IC, so hydrochloric acid. If you have oxyacid, so that means where you have a hydrogen ion and a polyatomic ion, so something like phosphoric or nitric, it's going to depend on whether the ion ends with an ATE or an ITE. So let's say it's like nitrate, it becomes nitric. So in this case, it'll just be nitric acid for something like HNO3. If we have something like, I'm just thinking of an ite ion. It's just not popping up. Let's say like nitrite in that case, which is NO2, then it will become nitrous and then acid. So that's how it works. Let's move on. I don't know why it's not working. I don't know why it's not allowing me. Okay, there we go. In terms of base naming is a bit weird. You just gotta like memorize it. In terms of bases, it's mainly like carbonates or hydroxides, and bases have a pH of greater than 7. They may feel a bit slippery and caustic. They taste bitter. Don't ever taste these acids, by the way. Not acids, sorry, bases, by the way. Common ones are something like NaOH, so sodium hydroxide, potassium hydroxide, barium hydroxide, but you may also encounter some of the other bases, so things such as sodium carbonate or sodium bicarbonate, which are also bases. I don't know again why it's not allowing me to move on. Okay, there we go. In terms of indicators, there's a few indicators that you will have to know. Indicators pretty much just help you, show when you have a change in pH, and that's through color. And these are typically inorganic acids that are in equilibrium. So the common indicators that you'll be using is methyl orange, bromothiamyl blue, phenolphthalein, and litmus paper. So for litmus paper, it's pretty straightforward. When you have red litmus paper and you test it with an alkali, it becomes blue. For blue litmus paper, when you test it with acid, it becomes red. So that's how it works. And you can just say acid is red and base is blue. That's how you kind of know the colors. For methyl orange, the transition range, when it's in the transition range, it looks orange, and when it's acidic, it's red, and when it's basic, it's yellow. The transition range is when it changes color, and that's around 3.1 to 4.4. And then similarly for bromothiamyl blue, it's acidic when it's acidic, it's yellow, and when it's basic, it's blue, and when it's in its transition range, it will be green. For phenolphthalein, it only turns pink when it's in its basic range, and that's pretty much when it's really basic. So that's when it's from 8.1 to 10. But before 8.1, it's pretty much clear, and when it's between that range, it's like a pale pink. And then for litmus paper, like I've explained, it's red when it's in its acidic range and blue when it's in its basic range. Alrighty. And you also will be doing an investigation just to look at the use of indicators as well as the characteristics. So a very common one is making indicator with red cabbage. And that's pretty much when you boil the cabbage and you let it cool, and then the extract that you have is an indicator. So just make sure that you kind of understand the practical of it, because you may be asked, like, you know, how would you use a natural indicator, and you'd be asked the steps in order to prepare it. And also you will need to know the properties and the products of acids and bases. So that's pretty much writing equations. You will have learned this in year 11, so hopefully it's not too jarring. So in terms of just regular acids and bases, so let's say something like hydrochloric acid and sodium hydroxide, you produce salt and water. You don't typically write heat as a product, but it's just good to be aware as to, you know, whether it's endothermic or exothermic. And the salt in this case for, let's say, HCl and NaOH would be NaCl and then H2O. For acids and carbonates, you produce salt, water, and CO2 gas. And then for acids and metals, you produce salt and hydrogen gas. So just be aware of the different products that you may be able to encounter. To test the presence of CO2, you would do the lime water test, and then for hydrogen gas, you can just use the pop test. Oh my god, it's not working again. Okay, there we go. You may also be asked to look at the different applications of neutralization reactions. So that's what, like pretty much acid-base reactions. The common ones I would say is chemical spills and antacids, and these are the examples that I used in my exams. So for chemical spills, you may have substances to be used to neutralize what has been spilled. So that is mainly sodium hydrogen carbonate, and that's because NaHCO3 can work with both acids and bases. So it's a substance that can act as both, which I'll get into later. It's also very cheap, and it's easy to, you know, be used and stored, and it's very stable as well. It doesn't change into other things and doesn't absorb water as well, which is really important. You may also be using antacids within everyday life, so that's through medicine, and these contain things such as aluminium hydroxide and magnesium hydroxide, and these pretty much neutralize the excess stomach acid when you have indigestion. So that's also a common application that you will be learning. And stomach acid is pretty much hydrochloric acid, if you're not aware. So whenever you're writing equations for these, you would combine, let's say, aluminium hydroxide with hydrochloric acid, and that's how you would write your equation. You'll also be required to conduct the enthalpy of neutralization. And neutralization is pretty much just having an acid react with a base, but if you want to simplify it further, you have pretty much hydronium reacting with the hydroxide to produce water. Hydronium may be really unfamiliar for you guys, so I will explain what it is later on, but just know that this is what the neutralization equation pretty much looks like. But you may be also asked to write the equation where you have the actual species involved. So for example, I don't know, sodium hydroxide and hydrochloric acid. And all neutralization reactions pretty much have the same change in enthalpy, and that is pretty much negative 57.3 kilojoules per mole. This is pretty much the enthalpy produced because you have water as a product. So just be aware of that. And neutralization reactions are always exothermic.